Hi everyone, welcome back to my YouTube channel SK Tech. In today's video, we are going to learn about the functional interface with the help of the example. And these are the topics that we are going to cover, like overview of the functional interface, key point about the functional interface, an example of some custom functional interface also. And also we are going to see some summary. So basic information about the functional interface we have already seen in our previous video as part of the lambda expression. I'm going to share the video link, so do check out for the more information. Okay, now let's begin. So first let's try to understand what is functional interface. So basic definition of the functional interface is like an interface which have exactly a one abstract method is called functional interface. So by this can we say any interface which have exactly one abstract method is a functional interface? The answer is yes. So any interface with a single abstract method is called as functional interface. Now the question arises, can we call any interface which have more than one abstract method as a functional interface? Because we know that inside the interface there can be a possible that multiple abstract method, right? So no, the answer is no. The interface which contain more than one abstract method is not called a functional interface. That is called a simple interface. But any interface which have exactly one abstract method, that is called as a functional interface. Okay, now let's see some key points. So first key point is like same, any interface that contain exactly one abstract method is known as a functional interface. Another key point about the functional interface is like it can have any number of the default and static method but can contain only one abstract method, because the definition of the functional interface is called like it can have exactly one abstract method. But there is a feature introduced by the Java 8 by which now as part of the interface there can be a default method and there can also be a static method which have some implementation also. So as of now till Java 7 we have seen like inside the interface we can have only abstract method, means signature of the method. There will not be any implementation of those methods. But now after the Java 8, or you can say interface can contain apart from the abstract method that is called static method and default method. We will see in detail what is default method, what is static method, and what is the reason behind to implementing this static and default method inside the functional interface. Okay. Now third key point about the functional interface is like functional interface is also known as a single abstract method, or you can say SAM interface. So SAM is nothing but single abstract method. So instead of calling the functional interface, we can also call as a single abstract method or SAM interface. Okay. So basically it is a new feature that is introduced as part of the Java which helps us to achieve a functional programming approach. And how it can achieve functional programming approach? With the help of the lambda expression. So we have already seen if we have an interface which have exactly one abstract method, we can use the lambda expression to provide the implementation for that abstract method, and that is like in a one line similar to the anonymous. No need to create any separate class to implement it, then provide the implementation, and for using that no need to create the object and use that. Using the simple lambda expression, we will be able to provide the implementation. And that's what we have seen couple of examples as part of the previous video. So do check out for more information. Okay, moving ahead, next important point about the functional interface that a functional interface can extend another functional interface only when it does not have any abstract method. So what is the meaning of this sentence? So we know that an interface can extend another interface, right? For example, let's say interface 1 is having method m1 and inside the interface 2, let's say method is having m2. So interface 2 can extend the interface 1. That was possible, right? And that is still possible. But that is not in case of the functional interface. Because if any interface is going to extend another interface, it means that the same method which is available inside the interface 1 will be automatically available inside the 2. It means that interface 2 can contain two abstract methods, but that is going to violate the functional interface definition, right? because functional interface can extend another interface only when does not have any abstract method, meaning at the end an interface which have only one abstract method is called functional interface. Other than that, it will call as a simple interface. That's what we have seen Java 7 implementation, right? Next key point about the functional interface we need to note down is like Java API has provided many interfaces which have already one abstract method, that is before Java 7 also. Like we have seen runnable interface. So that runnable interface which have run method, callable interface, that can have one abstract method that is called comparator interface, that we have method called compare, right? So all these interfaces was already available as part of the Java 7 only, and those interfaces also called as a functional interface because those interface can contain exactly one abstract method, and for those interfaces we can use the lambda expression to provide the implementation. We have already seen the example of runnable interface, callable interface, comparator interface and implementation as part of the lambda discussion in our previous video, right? So these are some key points that we need to know about the functional interface, like what is the functional interface and what are the properties it is going to hold. Okay, now let's see some couple of the interfaces which was already available as part of the Java 7 also, or you can say before Java 8, and some of the example that we have already seen. So first one was like runnable interface. So this interface also can call as a functional interface because this interface only contain the run method. Similar to the runnable, there is an interface called comparable. This interface also contain only one method, that is compared to. Another interface is like action listener. This interface contain exactly one abstract method called action performed. And callable. So callable and runnable is part of the threading concept only, and these are the interface which contain exactly one abstract method also, like run method and call method. So these are some of the interfaces which were already present before Java 8, and these interfaces also call as a functional interface because these are containing exactly one abstract method. Now let's see, there are some couple of the functional interface introduced by the Java 8 also, and also we will see like we can create our own custom functional interface which is going to meet the criteria of the functional interface. So this is like before Java 1.8. Now Java has also introduced some couple of the functional interface which contain exactly one abstract method, and we will see what are the uses of those methods. So first is like consumer, predicate, functions, supplier. So these are the interface introduced as part of the Java, and there are also couple of the interfaces which is sub part of these interfaces, like consumer is having by consumer, predicate is having by predicate, function is having by function, for unary operator, binary operator, and supplier is also having some different types of these sub functional interface. We will see what are these functional interfaces, what is the use of that, but as per the definition, all these interfaces is going to contain exactly one abstract method, and there will be some differences as part of the argument, like consumer and by consumer. So basically by means it's going to be more than one argument, like two argument. Similar to the predicate, there is a by predicate, function, there is a by function. Okay, now the question is like, can we create the functional interface? Like, can we create the user functional interface? So the answer is yes. We can create any interface and we can define exactly one abstract method, that is also called as a functional interface. Java also provide one annotation that is going to force, or you can say that is going to tell to the compiler this interface, or you can say Java user defined interface is called as a functional interface, and that annotation is called @functional interface. And this annotation is completely optional. We will see why it is optional and is it recommended to use or not, in which scenario we can use it, in which scenario we can ignore it. Okay, so these are some couple of the interfaces which is already part of this before Java 8, and these are some couple of the functional interface which is introduced as part of the Java 8. Okay, now let's see some example. So basically we are going to provide the implementation of all the functional interfaces that has been introduced as part of the Java 8, like predicate functional interface, function functional interface, supplier, consumer, by consumer functional interface, by function, by predicate. And we have already seen this interfaces implementation in our previous video, like runnable, comparable and callable, right? So do check out for more information like how we can provide the implementation of existing functional interface. In this video we are going to see with the help of the example which is introduced as part of the Java 8. Okay, and also we are going to see how we can create our own custom functional interface using the annotation provided by the Java @functional interface. And also we are going to see how that functional interface, or you can say functional interface annotation, is optional. Okay, so now let's go to the IntelliJ IDE and try to perform the operation on using these functional interfaces. So first of all, that you need to note down that the implementation can be provided of any kinds of the functional interface using the lambda expression, and we have already seen in our previous video. So same lambda expression that we are going to use as part of this video also to provide the implementation of all these functional interfaces. And we are going to see what are those methods available inside this each of the functional interfaces and when we can use which functional interface. Okay, so now let's go to the IntelliJ IDE and try to perform one by one. So first we are going to see the example of predicate functional interface. Okay, for the simplicity I have already created one class called functional interface demo, and inside that I created main method. So first we are going to see predicate functional interface. So let's write some comment here like predicate functional interface. Okay, so first let's try to understand what is predicate functional interface. First of all, it is a functional interface. It means that this interface is going to contain exactly one abstract method. Okay, so that method, what is that method? First we need to know what is predicate function. So when we can use this predicate function? So basically whenever we need a function for checking any condition. So a predicate is one such function accepting one single argument to evaluate the Boolean result. That is the basic definition of predicate functional interface. So basically it is going to contain one method called test, and this functional interface is useful when we want to perform some checks on various conditions. So and it is going to contain single argument. There is another method also like inside the by predicate which can contain multiple arguments. So basically this predicate function is going to contain one single method called test, and it is going to return some Boolean type. So basically if you see the definition of the predicate as part of the Java 8, it is already provided. If we write here like predicate, okay, if we go inside that we will see that there is a method called test, and this method return type is having Boolean. So basically this method is useful when we want to perform some checking inside the method and we want to return either it is true or false. So you can see that the definition like evaluates this predicate on a given number, means what are the number that you are giving. Inside that we are going to perform some checks. Based on the checks we are going to return either true or false. So in all those kinds of scenario where we want to check something and we want to return true or false, we can simply use this predicate functions, predicate interface. Instead of defining our own interface, defining our own method and provide the implementation, we can directly use this built-in interface provided by the Java 8, and we can provide the implementation using the lambda expression, and then we can use it. So we will see how it is. Okay, now let's see how we can do that. So let's say we have a class called person. Inside the person we have different kinds of the field. Person class this, and we want to check what is the age of the person. If the age is greater than 28, then we want to return true. If the age is less than 28, then we want to return false. Okay, so in those kinds of scenario, like let's say how we can provide the implementation. So in a traditional one, what we can do, we can write simple one interface, right? Let's say person interface, and inside that let's say we have created like one method Boolean and test age. Okay, let's say here we are going to provide the age value, let's say int something age, and here we are going to write some so since this is an interface, so let's say we have provided like some abstract method. Okay, and let's say we want to provide the implementation. How we are usually doing that? We are creating simple class, let's say class A, and where we need to provide the implementation of this personal interface. Okay, and inside that you are usually write implementation of this class, right? How you are writing it? So simply like this. So let's say we want to write the logic for checking the person age, and we are going to return true or false based on the age is greater than 28 or not. So how we are usually writing it? Like if age is greater than 28 or 28, then it is going to return true, else return false, right? So let's say we have given like public, basically it is giving some access things, right? Even this is by default public, right? By default public abstract. So let's say this is how we are providing the implementation. Now let's say we have a person information here, something like person P equal to new person. So let's say we have some information. So do we have any constructor which is holding the person information? Yes. So we can provide the age like let's say 29 and name let's say SKT. So let's say we have this information about the person and we want to check the person age is greater than 28 or not. So in our traditional one, how we are providing the implementation? So let's say we are having one interface called person interface. Here we have method called test age. So usually we are providing the implementation like this, and if you want to use this functionality to check the person age is greater than 28 or not, we are simply creating the object of the A class, something like let's say A1 equal to new A, and using this method, using this object A1, we are calling like let's say test age, and here we can pass the age of the person. So how we are passing? P dot get age. So this is going to return true if age of the person is greater than 28. So we are simply writing like boolean b equal to, and we are printing here let's say age of person is 28. This is some example. This is going to return true or false. Okay, and plus b. So this is how we are providing the implementation. So let's say we have some information here like this. We are providing the implementation, and if you want to use this functionality, so basically what is this functionality? This functionality is going to check the person age is greater than 28 or not. Okay, and to check that information, like to check the age of the person, we are using this functionality by this. We are creating the object, we are using this object, we are calling this function and providing the person age, and this is going to return true or false based on the age provided. So here we have provided age like 28. Okay, so what it is going to return? Basically it is going to return true. So let's wait for some time and see once this program is successfully run. Yeah, so if you can see here, this is printing like age of person is 28. So it is saying that yes, it is true because the age of person is 29, right? So this is how we are providing in a simple traditional one to the creation of interface and then implementation of that interface. So basically this is one of the functionality. Let's say someone has written, and we are, if you want to use that, we need to use in this way, right? So instead of creating our own function which have exactly one method that is going to test the age and providing the implementation using this way and using this here, what Java has comes to that, like Java has created one built-in function that is called predicate, which is going to provide one test method. Okay, we just need to provide the implementation. So since this predicate is having one method called test, which is going to accept one argument, the argument can be anything based on the type of creating the predicate interface, and then we are going to provide the implementation. Okay, so if you see that this complex code, we are writing this functional interface, then we are providing the implementation, and then we are using it. Instead of that, how we can replace all this boilerplate code using the simple functional interface and providing the implementation using the lambda expression. Now let's try to provide the implementation of this functional interface that is called predicate, and we'll see how it is easy and simple and clean. Instead of writing all this boilerplate code, we can write simply one liner of code, which is Java has already given this built-in predicate function. Okay, so let's try to implementation of this predicate function. So we know that this function is having one method called test. So we just need to provide the implementation using the lambda expression. How we can do that? So first we need to create the interface object, and also we need to provide the type of the predicate. So what types of the predicate information or implementation that we are going to provide. So if you see the syntax, it is asking some T type. It means it is a kinds of object, and same object it is going to accept here. Okay, so how we can do that? Let's say we want to implement this predicate function of type person, because we are going to perform the operation on the person object, right? So how we can do that? Here we need to provide the person type. It can be anything. It's just that what types of the data that you are going to supply for that particular predicate interface, and going to provide the implementation. So in this case it is a person type, because we are going to check the person age. If it is a different type like student type or employee type, so same type we need to provide it here. So this is basically a custom type. Okay, and then we need to create like one object, let's say person predicate, and here we need to provide the implementation. So how we can provide the implementation of any functional interface abstract method using the lambda expression? So it's very simple. First we need to write the standard syntax of the lambda for the simplicity to remind everything. So what is the syntax for the lambda? So that is this braces, then arrow token, and then this curly braces, open and closing, and here we need to provide the implementation. So that implementation is decided based on the type of the method available inside this functional interface. So we know that this predicate functional interface contains test method of type T. So type T is nothing but what types we have created. So that is like person type. So we need to provide like person type here only, person type of the object. So first let's say try to create the object of the person, and using this person we are going to provide the implementation inside here. So how we can do that? Let's say we want to write same logic. So let's say we want to get like person dot get age. Okay, and we are going to check if it is a greater than 28. Okay, if it is a greater than 28, we are going to return true, and if it is less than 28, we are going to return false. So what that logic, how we can write inside the functional interface? So since this information is already available inside this interface, we have created the person type. We no need to provide this. So it could be like this person, and then it should be like 28, and since this is a single statement, if you try here, so what it is going to do, it is going to create one local variable to hold that information. Okay, and it is let's say we are going to return it, return B1. So this is how we can provide the implementation using the lambda expression of any person type. Is it okay to write this one? Yes, it is okay, because we can provide the type here or not. That is completely optional. If it is a one variable type, or you can say if it is a one argument type of this method. If there is a multiple argument types, then we need to provide either both of the variable or none of the variables. That is completely optional. So this is how we can provide the implementation of functional interface using the lambda expression, and also we can simplify this. So we know that this person type is optional. We can remove this completely. This is also okay, and even since this is having a one argument, this braces is also optional. So we can remove this one also. You can see that compiler is not throwing any exception, and even this piece of code we can combine like one, since here we are returning return type because there is more than one statement. If there is only one expression and having return type, then we can remove this return type also. So this piece of code can be replaced simply directly returning this one. Instead of assigning it and returning it, we can remove this part also. Okay, so this we can simplify like this. Now is it any way we can simplify this piece of code also? The answer is yes, since this becomes one statement, right? So since it is a one statement, we can remove this curly braces also. So you can see that how sorted it is going one by one, And now this is a one statement, then return type is also completely optional. So we can remove this also. So you can see that how simpler it is. Instead of providing implementation using the creating of class, providing the implementation, we are able to write this piece of code in one liner in very short form. And using this object, we can call the method of the predicate function. So what is the method? That is nothing but the test. So let's say person.test. Okay, and here we can provide the person class object. So instead of creating like we are creating here, right? So instead of creating, we can pass here something like, let's say this, because this test method is going to accept the type of the data which is provided here. So since we have provided person type, so here it is going to accept person type object. So either we can create the objects outside and then pass it here something like p, okay, or let's say we want to use different data. So what we can do, we can create new person and let's say providing the age like 30, okay. And this method, what it is going to do, it is going to call this predicate function implementation. So basically it is going to check what is the age of the person. Is it greater than 28? If it is yes, it is going to return true. If it is no, it is going to return false. So basically this is going to return the boolean type, because the test type object is going to return boolean type. So similar to that, it is going to return boolean type. So either we can hold some in variable, let's say b2, and then we can print it something like this, age of the person is 28 or not, using the b2 object. Or we can call this expression here itself. Let's say instead of b2, we directly call this. This is also possible. So let's remove this. So see that using the single statement, we are able to write this piece of code. So unnecessary writing this implementation, this class, providing the implementation and using it here using the object, using the lambda expression and using the predicate function interface provided by the Java, we no need to write this piece of code. We simply use this one. So it is similar to like how we are creating simple functional interface, providing our own abstract method and providing the implementation using the class, and using it if we have a requirement, and then we need to see is there any other already functional interface available which is going to do the same thing. So instead of creating our own, we can use directly, like in this case predicate. Okay, we know that predicate is having a test method, and inside the test method we can write logic, some checking logic. Like here we are writing the logic like checking, like age is greater than 28 or not. Now let's run this program and see the output. So let's write here lambda, using the lambda, or you can say functional interface and lambda. Okay, so that will be more clear. So let's run this program and see what is the output is going to print. So see that this is also serving the same purpose, right, that we are providing, or we can say we are achieving using this, writing this piece of code. The same purpose is going to achieve using the functional interface, predicate and lambda expression, providing the implementation of functional interface. Okay, so this is it about the predicate functional interface. Now let's move ahead and see the next functional interface available inside the functional interface. That is nothing but functional interface. So since this is also a functional interface, it means this is also going to provide one method which we are going to use. Either we need to create our own and then provide the implementation something like this, or we can use directly the functional interface and provide the implementation. The thing is like we just need to remember what types of the method available on those kinds of the built-in functional interface. If we have a requirement to create similar types of the interface, so instead of creating our own like this, we can directly use that, and using the lambda expression you can provide directly implementation also, like in this one liner of the code. So you see that how simpler it is. Instead of providing this long piece of code, we are able to write the same implementation in a one line, right? Now let's see what is functional interface first, and then we will see with the help of example. Okay, so what we can do, let's try to comment it out this piece of code. Okay, or what we can do, we can write some simple sysout statement to separate it out. So let's write something like function functional interface. Okay, and similar statement we can write here also, since we have seen this example with the predicate functional interface. So let's write down here, and then this piece of code let it be as it is. Just we have written for the demonstration purpose, like how we can write our own traditional one and how can we replace this piece of code with the help of the functional interface implementation. So we have seen predicate function. Now we are going to see function functional interface. So before going to see what is function functional interface, so as we know, it is also going to contain exactly one method. So that method we need to see, and according to our need we can use that. So there is a two way always, either we create our own and provide the implementation, or we can use the Java 8 and you can use the pre-built, or you can say built-in functional interface according to your need. So let's try to use let's type like function. Okay, and this is also a functional interface. Now let's try to see what is the method available inside that. So since it is a functional interface, it is also going to contain one method. So see the definition here. So it represents a function that accepts one argument, and also it is going to return another types of the argument. So like how we have seen in case of the predicate, it is expecting one object type because we are passing it here, then same type it is here. It means it is accepting one object type but returning boolean, means primitive type, right? So you can see that the function interface contains exactly one abstract method, that is called apply. Okay, and this is what it is going to contain. It is going to accept one object type and going to return it another object type. So let us create an example to demonstrate the uses of this function functional interface, then it will be more clear. So just we need to remember here is like, while creating the object of the function functional interface, we need to provide two object type, where first object type is going to accept as an argument and another object type it is going to return. Okay, so this piece of information that we need to know, and we will see how it is. Okay, so this piece this function functional interface, when we can use it. So basically one use case could be like when we are converting centigrade to Fahrenheit. Let's say we have a requirement, we want to convert one type to another type. So let's say we have two types, we want to convert one type to another type. In those kinds of scenario, either we can create one functional interface and provide here two argument, and using this implementation we can provide the implementation and use it, or we can use Java provided built-in functional interface and provide the implementation using the Lambda. So this functional interface is going to use when we have a requirement to convert from one type to another type. For example, let's say we want to convert centigrade to Fahrenheit. So how we can do? Using the traditional one. So in the traditional one, what we can do? Here we can write something like two argument type. Here we need to write the logic, and we are going to return the another type. Okay, or we can use the built-in functions like function functional interface. Function functional interface is useful when we want to convert one type to another type. So we need to provide source and destination, and we are expecting like destination provided is going to return. Okay, so let's say we have a requirement like convert centigrade to Fahrenheit. Okay, so basically when we have any these kinds of the requirements converting from some type to some type, so in those kinds of scenario we can either create our own functional interface, provide the abstract method like two argument type, because it is required from some type to another type. It means two argument is required, and also it is going to return type of that type is going to be a destination type, right? In those kinds of scenario, this functional interface is going to be very useful. So we can use this function functional interface. Let's say we have a two different type, let's say integer and double. Why it is a two different type? Because in centigrade can be a integer type, but Fahrenheit can be a double type, because it is going to hold some decimal value. So those value can be stored inside the double, not as part of the integer. So we are providing two types. So what we are going to do, we are going to convert the integer value into the double type, or you can say centigrade value to Fahrenheit type, and going to return the Fahrenheit return type. Okay, so if we are providing these two argument here, so what it is meaning, it is going to do the operation on the integer type, going to convert into the double type, and going to return the double type. So instead of providing our own complex logic here, like something like this, how we can do that in the traditional world? We simply write some method, something like, let's say we want to return type as a double, so we simply like double and some method, let's say convert, and here we need to write like integer, let's say I and double D. So this is how we write the logic, right? And then here we need to provide the implementation. So let's say we write the implementation like this, convert, and here we are going to return the D type. So basically here we are going to write the logic for converting, and we are going to return as a double type, because centigrade is converted to Fahrenheit type, means this is going to return as a double type. So the same thing we can simulate it using the traditional one. Okay, so we can comment it out like, let's say this, and provide the implementation, and using that we can use it. Okay, so for now let's try to revert it, because since we have already provided the implementation, so this is going to throw some exception. So there is a two way, let's try to comment it out for the simplicity. Okay, let's try to comment it out here like this. So this is the traditional one, and since we have an interface which is going to provide these types of the method and return type also, so instead of creating our own, providing the implementation, we can directly use the built-in one. That is because we can use the lambda expression, we can provide the implementation in a one line, and we can use it instead of writing this long piece of code, right? So since functional interface is also a kind of same type, it is going to accept two types, one is like, let's say integer, one is like double. It can be any other type also. We will see some more example, then it will be more clear. Okay, then we need to provide like some object, and here we need to write the lambda expression to provide the implementation. So for simplicity, what we need to do, first we need to write the syntax of the lambda expression, that is nothing but this, right? And then we can start the implementation. So since this lambda expression, or you can say this functional interface, is containing method which is accepting two arguments, and those two arguments is nothing but this one only. So let's write down here first. We'll see one by one how we can. First we need to familiarize with the syntax and all the optional concept. Then we can, once we will familiarize, we will be able to remove all this boilerplate code at one time only. Okay, so let's write like centigrade like C and Fahrenheit like F, and here we can write the logic for converting. So what is the basic simple logic to convert the centigrade to Fahrenheit? It's very simple. What we need to do, we need to write like there is some math formula that you can go through the online to get the formula logic. It's very simple, is like C plus 9 divided by 5. So this is a variable value that is going to come as an input, and based on this like 32, this is going to return as a double type, and also it is going to convert to the Fahrenheit type. So to return to the double type, what we can do, we can simply write like new double. Okay, and let's try to hold this all information inside the double, and here we need to write like return statement, and this, what it is saying, expected. So we have already given. Okay, so there is some braces missing. Okay, like this. Okay, so here we have done some mistake. Basically this functional interface is having a method and which is required to accept the first type and return types to the second type. So what we need to do, we need to provide the one argument only of type this. Using this variable, we are providing the implementation and converting it into the another type. So what is the another type? That is nothing but the double. That's why we are converting it here. So this is very simple logic. We can use this, and using that we will be able to convert centigrade to Fahrenheit, and also we can provide the similar implementation that what we have written it here, right? So you can see that using the one liner of code, we are able to achieve this function interface, like this custom function interface, providing the implementation and using it here. Instead of that, we can use the built-in function interface, which is going to accept two argument type, where first argument type is going to be input and another argument type is going to be output. So in this way we will be able to write the logic in a single line and in a very convenient way, right? And again, this expression we can optimize it, like since this is a one argument. So first this data type is optional in case of the lambda expression. And next important thing is like this braces. This braces is optional if it is a single argument type. And next thing we need to think about here is like, since this is a one statement, this return type is also a optional. So even you can remove the return type. And now you see again this piece of code is like a single statement, right? So this curly braces is also a optional. So you see that we are going one by one, step by step. So you also need to practice this step by step, so that you will be familiarized soon and will able to understand what is the syntax, how we have written it. So first we need to write one by one, like we have to write the syntax of the lambda expression, then we need to provide the argument, then token arrow inside the body of the lambda body, we need to provide the implementation, and then slowly, or you can say step by step, we can see what are the optional thing we can remove it. Like we have seen, data type is optional if it is a single argument type or multi argument type. Braces is optional if it is a single argument type. Return type is also optional if it is a single statement inside the lambda body, and similar to that, curly braces also was a optional. Okay, so you see that this piece of implementation we are able to write in a very single line using the lambda expression, and this functional interface we are able to provide the implementation. Okay, now let's try to use, or you can say let's try to call the function and provide the value, because here we need to provide the value of the C. So how we can provide it? We need to use this object, then we need to call the apply method. This apply method is nothing but the part of the function interface, and here we need to provide the value. So let's say we have provided the value like 4, this, and what it is going to return? It is going to return as a, so this value is going to be considered as a centigrade, and it is going to return as a Fahrenheit, right? And the type of the Fahrenheit is like double type. So basically this is going to return double type. So what we can do, we can either create the double type, okay, and store it and then print it, or we can directly use this method calling inside the sysout statement only. So let's try to familiarize with this concept only, because for testing purpose no need to hold inside the another variable until and unless we are going to perform some other operation on top of that. If we simply want to print it, we can use simple sysout statement and print it like this. Okay, so let's say write some statement here, so for the simplicity, so that it will be more visual. Okay, so what statement we can write it like something like this. Let's say same statement here, Fahrenheit to, I mean centigrade to Fahrenheit. Okay, now let's run this program and see the output. Okay, so what it is saying, deprecated Gradle function, what does that mean? Okay, that is like warning, not the exception. So see that output is like converting centigrade to Fahrenheit. Basically it is converted this centigrade to Fahrenheit using this formula. This is very simple formula to convert any centigrade to Fahrenheit. You can go through any online tools and you can get to know what is the formula. Okay, but here we are just want to discuss like functional interface, like when we can use it. So this is useful when we want to convert one type to another type. So instead of providing the implementation like this, creating the interface, providing the implementation and using it, we can directly see Java has already provided one interface, that is functional interface, which is also going to provide these types of the method, or you can say these types of the abstract method. And using the lambda expression, we can write the logic something like this. Similar to that, let's say we have a requirement. Let's try to demonstrate it with some other example. Let's say we have a requirement to convert string to an integer. Okay, so again we see here there is a two argument, or this is the different types of the argument. What we want to perform it here, integer to string to integer, it means one type to another type. So either we can write the simple method, or if we are using interface and class implementation, we can write something like this. Or since it is one type to another type, then we need to remember Java is already providing one functional interface that is also going to provide one method going to accept the one type and going to return the another type. So we just need to know, like if it is having any requirement where we want to pass one argument type A and we want to return the another argument type B. So in those all kinds of scenario, we can go for the functional interface. So let's see some couple of more example and try to familiarize with it. Okay, so let's try to implement this functional interface. So this time this source type is going to be string and destination is nothing but the return type is going to be integer. Okay, so let's write here something like string integer functional interface, that could be anything. Then here we need to write the implementation of this functional interface using the lambda. So again we are going to follow the one by one, step by step. So first we need to write the syntax of the lambda expression. So what is the syntax? That is nothing but this, right? So we know that it is having one method which is going to be a one type, this type, and return type is this. So how we can do that? So first we need to write like string and input, let's say s. Okay, it could be anything, it's just that we want to write like, let's say here what we are doing, string to integer. No need to write this, it is a very long statement. This is for simplicity, we can write like something this. And let's say we have given the variable like x, it could be anything, it's just that for the simplicity I have given the x. And here we are going to write the logic for conversion. So how we can convert the string to integer? It is very simple. We can use the value of method inside the integer class, right? So like integer value of, and here we can provide this variable. Okay, so basically this is going to return, so this is going to return the integer type, right? So let's write this statement. Okay, so this is how we can provide the implementation of one type to another type conversion, or one type as an argument and another type as a return type. So in those kinds of scenario we can use the functional interface. Now let's try to use it, then we'll try to simplify this expression again. Let's write some simple statement like sysout and some statement like string to integer conversion, and we are going to use this object dot what are the method available. So here we need to provide the input types. What could be the input type? Input type should be first type, like string type. So let's say we providing like 4, it should be integer convertible, that is the simple logic, right? You want to convert string to integer, so string should be convertible to integer, otherwise it is going to throw some number format exception. That is a very simple Java logic, right? So let's try to run this program and see the output. So yeah, you can see that it is printing like string to integer 4. Okay, now let's try to simplify this expression again. So how we can simplify it? So let's try to write inside the comments so that it will be more easy. So first what we are going to see, this is the statement. So how we can simplify it? So first thing is like this data type. So this data type is a optional. So the same statement can be written like this, right? Next simplify is like, since it is having a one argument type, so this braces is optional, right? So this braces is optional means this can be written like this also. This is also going to work. Next simplify is like, this is having one statement, right? And this statement, or you can say this expression, is going to return something. If it is having a one statement and it is having a return type, then return type is optional. Okay, so again this piece of code should be written like this. Okay, and now this is also not required. Now let's say we can simplify this statement again or not. So yes, this is a single statement, and in case of this single statement, again this curly braces is optional, right? So this statement can be written like this. Okay, so what we have done here, data type is optional. What we done here, so basically this braces is optional. Okay, in next statement what we have done, so here like return type is optional, right? And again in the last what we have done here, this curly braces is optional. That's what we have seen. Now we have simplified using this. Now let's try to write the sysout statement, okay, or you can say expression of this, and try to test it. Is it really working or not? So this expression we have already tested, we have printed it, and it is working fine, right? Let's write it here. Okay, now we are going to see. So this is when this was the case, right? Or you can say inside here. Now let's try to use this one, this all four, and see it is working or not. We need to test it, then only we will be able to get the confidence like this is going to work. As per the definition we have seen, it is going to work, but we need to test it one by one. So let's try to create the functional interface like this, something like functional interface integer 1, and let's try to write the, okay, let's put it above so it will be more visible, and let's try to write this logic. So see that it is not throwing any compile time exception, it means it is going to work. Let's try to print it again and see. So this time we are going to use like 1 and 1, and similar to that let's try to copy paste this and write the logic for this, and for this. Let's remove this last one. Okay, so let's try to use some different variable 2, 3 and 4, and similar to that let's try to use it here 2, 3 and 4, and let's try to replace this expression. Okay, so see that it is not throwing any exception. Now let's try to replace this statement again here, and also this statement, and let's try to print it. So let's run this program and see the output. So what it is throwing, okay, here, okay, terminate, here we have missed one statement, right? What it is saying, it is expecting this integer or this, add a return type. Okay, since we have provided this curly braces, if curly braces is there, then return type could be mandatory. Okay, so now here we cannot remove the return type if we have this curly braces, but curly braces and this expression could be simplified. So that's what we need to test it. See, during the testing only we got to know if this curly braces is there, then we need to write this statement, even it is a single statement. Okay, return. So see that now it is not throwing exception. So basically what we have done, so this curly braces is optional also. So what we can write it here, right? Return and this curly braces at the same time. So this we have to test it, then only we'll get the confident like whatever the things that we are saying, is it really working or not. Now let's try to run this program and see the output. Yeah, so you see that all are printing, right? All are printing, since this is the same statement we have written. So we can update it, and also we can see that. Let's run this program and see the output. See that the same expression is working seamlessly, similar to this one, right? So basically at the end, what we got this expression, basically we are able to write this like this, right? So since we have written like this could be optional, right? This is what we have not tested it, but we have written it like this, return, and this curly braces is optional. See, it is printing now also. So this expression, this piece of code is replaced with the simple this piece of code. It's very simple, right? So this is how you need to practice more and more, then you will get to know what are the parameter, what are the data type, what are the curly braces is optional. So now here we have demonstrated each and every optional piece of code which is presented here, right? So it's a very long video. Okay, so we have some couple of more examples that we wanted to demonstrate here, like supplier functional interface, consumer functional interface, buy functional interface, buy consumer functional interface, predicate, you can say buy predicate functional interface. We have already seen predicate functional interface, right? And also we have not tested like custom functional interface. So basically those all example we are going to see in next upcoming video, and also we are going to see some more example, some more complex example of the functional interface. So here we have seen some primitive data type, right? Now we need to see the some real time example also, like person type or department type. So those all example we are going to see in next upcoming video. Okay, so till now if you have any comments, do let me know in the comment section. I'll be checking all the comments actively, and I'll try to reply, or you can say I'll try to answer all those questions that is pasted inside the comment section. Okay, so stay tuned, we'll meet you soon with more interesting example in the next upcoming video. Thank you.